Here you'll learn about the tangent function. But first, let's make sure you remember the sine and cosine functions. Here's a right triangle, and let's say its sides have length 5, 12, and 13. Let's also label this angle with the Greek letter theta. What are the sine and cosine of theta? If you'd like to review the sine or cosine functions instead, click down here. Good. You remembered that the three sides of a right triangle are called the hypotenuse, opposite, and adjacent. The sine of an angle equals the opposite over the hypotenuse, while the cosine equals the adjacent over the hypotenuse. Now the tangent function, written as tan, equals the opposite over the adjacent, and that's it. So for this triangle here, what's the tangent of this angle theta? So now it's time for you to calculate the tangent of an angle using this interactive right triangle. You can drag around this corner in the upper right to make any right triangle you want. As you move the corner, you'll be changing this angle down here. Also shown here are the lengths of the hypotenuse, opposite, and adjacent sides of this triangle. So try using this interactive right triangle to find the approximate value of the tangent of 60 degrees. And if you're not sure how to get started, feel free to ask for a hint. Great work! Now use this interactive right triangle to find an angle whose tangent is approximately 0.9. Again, feel free to ask for a hint if you need one. Great! So to summarize, here are the side names of a right triangle, and here are the definitions for the sine, cosine, and tangent functions. Now it turns out that these three functions are actually related to each other. See if you can find a way to write the tangent of theta in terms of the sine of theta and the cosine of theta. If you're not sure how to do this, click here and we'll break this problem down. Very well done. For any angle theta, the tangent of theta always equals the sine of theta divided by the cosine of theta. Try using this fact, or trigonometric identity, to solve a sample problem. If the sine of an angle is 0.6 and the cosine is 0.8, find the angle's tangent. Say you have a right triangle, and let's say you also know that the hypotenuse has length 14 and that this acute angle over here is 50 degrees. Your task here is to find the lengths of the right triangle's two legs, over here and over here. If you already know how to find these lengths, then go for it and round your answers to one decimal place. And if you'd like to learn how to do this, click here to get started on this lesson and to learn about components. Okay, let's get started. Let's not worry about specific lengths or angles just yet. Suppose that the length of this triangle's hypotenuse is h, and that this angle here has measure theta. First, let's find the length of this side over here, which we'll call y. So we want to find y in terms of h and theta. Now we said that this side of the right triangle is called the hypotenuse, and this side over here is opposite from the angle theta, so this side is called the opposite. So which trig function uses the opposite and the hypotenuse of a right triangle? If you're not sure and want to review, click down here. Exactly, the sine function uses the opposite and the hypotenuse. More specifically, the sine of an angle theta equals the length of the opposite divided by the length of the hypotenuse. So for this triangle here, we said the opposite has length y, while the hypotenuse has length h. That means the sine of this angle theta equals y over h. Our goal was to find y, the length of this side, in terms of h and theta. Try using this equation to solve for y. Nicely done. You multiplied both sides by h to find that y equals h times the sine of theta. So that means the length of this side over here is h sine theta. Next, let's find the length of this side down here, which we'll call x for now. So we want to find x in terms of h and theta. We already said this side of the right triangle is called the hypotenuse. Now this side down here, which is the leg that's next to this angle theta, is called the adjacent. So which trig function uses the adjacent and the hypotenuse? Again, if you're not sure, just click down here to review. Great, you remembered that it's the cosine. Now the cosine of an angle equals the length of the adjacent divided by the length of the hypotenuse. Now in this triangle, we said that the adjacent has length x and the hypotenuse has length h. So the cosine of this angle theta equals x over h. We were trying to find x, the length of this side down here, in terms of h and theta. Use this equation to solve for x. Great! You multiplied both sides by h to find that x equals h times the cosine of theta. So this side down here has length h cosine theta. So if you know the hypotenuse of a right triangle and one of its acute angles, you can use the sine and cosine functions to quickly find the lengths of the right triangle's legs. To find the length of the leg opposite the angle, multiply the hypotenuse by the sine of the angle. And to find the length of the leg next to the angle, multiply the hypotenuse by the cosine of the angle. In physics and engineering, you'll often hear the legs of a right triangle also being called components. So for example, you could call this leg over here the hypotenuse's vertical component, while this leg over here is the horizontal component. Okay, let's return to the numbers we had at the beginning. We said the hypotenuse has length 14, and this angle over here is 50 degrees. So find the lengths of the horizontal and vertical components and round your answers to one decimal place. And remember, you can evaluate trig functions using the calculator down here. Great work! You multiplied 14 by the sine of 50 degrees to find that this length is about 10.7, and you multiplied by the cosine of 50 degrees to find that this length is about 9. Finally, let's look at a real-world example to see why components matter. Suppose this is a stretch of highway, and there's a police cruiser parked over here. Now the state trooper is sitting inside the car, pointing a radar gun at the oncoming traffic. When you drive through the beam of the radar gun, the officer can see how fast you're driving. Now suppose your car is directly in the beam, and let's say you're driving along at 70 miles per hour, just a little over the speed limit of 65. Now the thing to know about radar guns is that they don't actually measure your speed or velocity, they only measure the component of your velocity in the direction that's directly pointing toward the radar gun. So let's say there's a 25-degree angle between the direction you're driving and the direction of the radar gun. So how fast does the radar gun say you're driving? In other words, what's the length of this component of the right triangle over here? Round your answer to one decimal place. Well done! The radar gun thinks you're going 70 miles per hour times the cosine of 25 degrees, which is about 63.4 miles per hour, just under the speed limit of 65. But don't think this means you can drive over the speed limit. A good police officer knows trigonometry and takes the angle they're pointing the radar gun into account. So if their radar gun says 63.4 when you're driving at an angle of 25 degrees, they'll work backwards, see you're going 70, and pull you over. Here we'll introduce three more trig functions: secant, cosecant, and cotangent. Don't worry, they're not too different from sine, cosine, and tangent. To get started, take a look at this right triangle, and suppose its sides have lengths 3, 4, and 5. And let's also call this angle over here theta. First off, what's the cosine of this angle theta? If you'd like to review the cosine function instead, click down here. Right, cosine is adjacent over hypotenuse, so the cosine of this angle theta equals 4 over 5. So that's the cosine of theta. Now the secant of an angle, written as SEC, is defined as being 1 divided by the cosine of that angle. And that's it. So what's the secant of this angle theta? Nicely done. The cosine of theta is 4/5. So that means the secant of theta is 1 over 4/5, or 5/4. Great. So the secant of an angle is just 1 divided by the cosine of that angle. Before we move on to cosecant, let's make sure you remember how to find the sine of this angle theta. Right, the sine of an angle is opposite over hypotenuse, so the sine of this angle theta is 3 over 5. So that's the sine function. Now just as the secant is 1 over the cosine, the cosecant written as CSC, is 1 over the sine. So what's the cosecant of this angle theta? Precisely. The sine of this angle is 3/5, so the cosecant is 1 over 3/5, or 5/3. Finally, we'll be looking at the cotangent function, and you can probably guess what that is. But first, let's evaluate the tangent of this angle theta. Nicely done. The tangent is the opposite over the adjacent, so that's 3 over 4. And as you might have guessed, the cotangent, written as COT, is defined as 1 divided by the tangent. So try evaluating the cotangent of this angle theta. Nicely done. The tangent of this angle is 3 over 4, so the cotangent is 4 over 3. And there you have it. Secant is defined as 1 over the cosine, cosecant is defined as 1 over the sine, and cotangent is defined as 1 over the tangent. You'll probably remember that cotangent is 1 over the tangent, but remembering that secant is 1 over the cosine while the cosecant is 1 over the sine can be a little tricky. Don't worry too much about these. You'll usually just see expressions written in terms of sine, cosine, and tangent, but it's a good idea to know these functions for when you encounter them. At this point, let's take another quick look at the cotangent function. Cotangent is defined as 1 over the tangent. So what's the cotangent of theta in terms of the sine of theta and the cosine of theta? Precisely. Tangent is sine over cosine, so cotangent equals 1 over sine over cosine. You can simplify this fraction by multiplying the numerator, 1, as well as the denominator, this fraction here, by the cosine of theta, to get cosine theta over sine theta. So cosine over sine is an equivalent expression for cotangent. So now it's time for you to calculate the cosecant of an angle using this interactive right triangle. You can drag around this corner in the upper right to make any right triangle you want. As you move the corner, you'll be changing this angle down here, and also shown here are the lengths of the hypotenuse, opposite, and adjacent sides of the triangle. So try using this interactive right triangle to find the approximate value of the cosecant of 40 degrees. And if you get stuck, feel free to ask for a hint. Great work. Now one last question. Use this interactive right triangle to find an angle whose secant is approximately 2. This is a challenging question, so if you're not sure how to get started, just click over here.